How's it going, everybody, and welcome back to our Enterprise Practice Lab. In this video, we're going to continue with getting the HQ location operational. I do have my Disturbed shirt on from seeing them in concert over this past summer. Good show. Metalhead, totally. So what we're going to be doing, let me go ahead and pull up the PDF real quick, is this. We're going to be focusing on getting Nexus distribution, Catalyst distribution, and a routed core. So in other words, we're going to be getting these switches right here, these switches here, these switches here, all connected to this core connection. And then I'm going to go ahead and one thing that I didn't do at the very end of the VXLAN section down here at the bottom, it says apply VRF ETH enterprise to ETH 1/2 on the leaf switches. So right here, right, that's where we're supposed to do it. And then form eBGP peerings to the core routers. That'll be the next piece that we would have to do, and then advertise subnets into BGP. So technically speaking, that's already done, right? If we were to pull up, where did secure CRT go? Right here. If we were to look on Nexus 9K8, if we look at, this is the routing table, right? We've got the subnets advertised. So we've got 172.16 right here, right? And then 172.16.100 right here. So we've got the subnets advertised into the routing table. And if we were to look at the connectivity, and if you're ever curious to see how that works, look at the layer 3 VNI of VXLAN, and then you should see any of the subnets that you're advertising into BGP will be right there as type 5 routes, which are external routes to the VXLAN fabric. So with that being said, we can go ahead and we're going to do that last. We'll go ahead and get the peerings up and running to the core switches and get them all squared away. So that's going to be the next piece. Now, because of the fact that we're going to be focusing here in the middle, I'm actually going to zoom in a little bit to get a bigger topology while we're in the video. And I'm going to go ahead and pull this back up and scoot this guy down just a touch so that we can have the connectivity where we need it. And if once we get to that pair, we'll go ahead and do that. But I want to be able to focus solely on getting the connectivity up where I need it. So without any further ado, let's go ahead and pull up the PDF, scroll back up to the top, where we're going to do the core. So our Nexus distribution, Catalyst distribution, get that all squared away. I'm going to go ahead and get out of the way, and we're going to go ahead and dive in. So first thing it says, enable EIGRP on Nexus switches. So that means on, let me go ahead and get the connectivity up and running on switch 21 and 22 first, because that doesn't require any additional configuration. Let me bring 22 over here, like so. Okay, so switch 21, we're going to go to global config. I'm going to type in router EIGRP1. We're just going to use that as a simple capability. And then I'm going to use do show IP interface brief. And we've got 10.14.21. And then I want to advertise the VLANs into EIGRP. And one of the things that I'm going to be doing is doing passive interfaces on the SPIs so we don't accidentally form EIGRP adjacencies downstream. Because let me walk you through that logically. The HSR, we got HSRP set up on our Catalyst switch distribution layer. What I don't want to end up having is what I do want to have happen is I want an EIGRP adjacency here and an EIGRP adjacency here. Once that's up and running, that's what I'm expecting to see. I don't want to form an EIGRP adjacency across, although technically it won't work because of the fact that these interfaces right here are not set up as trunk links. They're simply just there. So with that being said, if I were to form an EIGRP, enable EIGRP on these interfaces right here, what's going to end up happening is I will end up forming EIGRP adjacencies through the access layer switches this way. And I don't want to do that because I've already got a mechanism in place for gateway redundancy. I don't need to do it through a routing protocol. So I'll advertise the routes, but I'll make sure that they're passive. So let me go ahead and get that process started. So I'm going to go ahead and get out of the way. I'm going to type in network of 10.14.21.0.0.0.255, and I'll do we'll do router ID. This EIGRP router ID is going to be 10.0.0.21, and I'm also going to specify network. In this case here, it's going to be 10.1.10.0, 0.0.0.255, and then 11.255. And I'm going to type in passive interface default. So they all go passive for what we need, and I'm going to say no passive interface gig 0/0. So what that basically is saying is I want to enable EIGRP here between switch 21 and CSR 14. I want the router ID to be 10.0.0.21. I want to advertise these two subnets into EIGRP. All the other, and these interfaces are passive. So, which means they're going to be advertised into EIGRP, but they won't form EIGRP adjacencies out the SPIs. And no passive interface gig 0/0, so that will form the EIGRP adjacency out to CSR 14. I'm going to do the exact same thing onto switch 22. So if I type in router EIGRP1, type in EIGRP router ID is going to be 10.0.0.22. Network is going to be 10.7.22.0, 0.0.0.255, and then I'm going to do show IP interface brief. Type in network of 10.1.10.0/24, and then 11. I'm going to type in passive interface default, no passive interface gig 0/0. Do show run pipe section EIGRP. And there's the commands. Everything's there, everything's looking good. So that's that. So now that I have that piece in play, screw this back up. So what I'm going to need to go do is go enable EIGRP on the outside, so on Nexus. So let me jump over here to Nexus 1. We'll go ahead and log into him. Go to global config and feature EIGRP. I need to type in router EIGRP1. Type in the router ID is going to be 10.0.0.1, and then log adjacency changes. I'm going to go ahead and log out, get out of there. I'm going to go to interface eth 1/5 and type in IP router EIGRP1. And I will do show IP interface brief. We're going to interface VLAN 20, IP router EIGRP1, VLAN 21, same thing. Now I'm going to go back to EIGRP1 and type in passive interface default, no passive interface eth 1/5. No passive interface. Oh, you know what? Interface VLAN 20, IP router EIGRP1. Is it EIGRP1? No. What's the passive interface command on that one? Router EIGRP1. Passive interface default. No. Passive interface default. Yeah, see, it looks like it's a one or none. Okay. I thought there was a more specific command. That's okay though if I do that, even though I don't want to learn the adjacencies. Actually, yeah, I don't technically want to do that. Show IP, and I haven't done any further. Let me pause real quick to see if there's any documentation that'll back that up. So this would be, so in the lab exam, the documentation is actually available to you. You just can't go to Google and search for it. You need to know how to navigate to it. So what that would look like is if I was to come over here to enterprise infrastructure, and I don't exactly remember where it's at. So let me go over here to cisco.com. Let me go ahead and get out of the way here. And we're going to go to support. We're going to go to view all product support. We're going to look at switches. I'm going to look at Nexus 9000. Nexus 9000 series switches. I'm going to look at documentation. I want to look at configuration guides. And going to go look at configuration guides of this type. And then we're going to go, let's see, I'm looking for unicast routing. I don't see what I'm looking for. Okay, so I'm in the wrong area. Let's see here. Let me go back up here. So there's another way of looking at product support. You can look at iOS network software. That's what I'm looking for. I don't want the specific switch. I want NXOS software. Sorry, that's where I should have gone. And then documentation. And then I want configuration. And then configuration guides. I am looking for configuration guides for the Nexus 9000. And then I'm looking for a specific release. I'm looking for 9.3. 9.3, and I'm looking for unicast routing right here. And then what I get to go do is look under EIGRP, and then I get to look at advanced features. Let's see, does it discuss passive interfaces? I don't see it doing anything. Let's say passive. There we go, configure a passive. So IP passive interface, EIGRP. Okay, so it's at the interface level. So you can do it globally, right? So that was the mistake we were making. So come back over here. And we're going to type in interface VLAN 20. Type in IP passive interface, EIGRP 1. There. That'll do the trick. 21. So that would be a perfect example of, you don't remember exactly what you need to type in or where you need to type it, but that's a quick way of looking up the documentation, knowing where to go. I couldn't Google it, but I had to remember the navigation path. So that's basically how you would do that. So I'm going to do the same thing on Nexus 9K2. Nexus 9K2, we're going to log in. Go ahead and do feature EIGRP. Router EIGRP1. Router ID is going to be 10.0.0.2. We're going to type in passive interface default, and then I'm going to go to, zoom up here a little bit, interface ETH 1/5. We're going to say, actually, no, I need to go back to the router EIGRP, no passive interface default. Interface ETH 1/5, IP router EIGRP1, interface VLAN 20, IP passive EIGRP1, same thing with 21, just like that. So show IP EIGRP interface brief, we have that, and if I do show IP EIGRP, we'll see that it's enabled. We do interface IP EIGRP interfaces. It's enabled there, but you'll notice that it is not enabled on the SVIs, which is what you want to see. Okay, so the next one would be doing Nexus 9K3 and 4. Login as admin. Feature EIGRP. And then we're going to do router EIGRP1. And we're going to do router ID is going to be 10.0.0.3. And then log adjacency changes. That's what I forgot to type in on the other one. Nexus 9K1. Log router EIGRP1. Log adjacency changes. do that on 2 as well. Router EIGRP1 log adjacency changes. And then on 3, we're going to do interface ETH 1/6, IP router EIGRP1, interface VLAN 200, and we're going to type in IP router EIGRP1, but IP passive EIGRP1, and show IP EIGRP interface. Yep, that's what I thought. So show run interface VLAN 200. Okay, perfect. So that's why I need to do that on 1 and 2 as well. So show run interface VLAN 20. Okay, so it's already there. Good. IP passive on both. Show run interface VLAN 21. Okay, interface VLAN 21. IP router EIGRP1. Perfect. And then we'll do 20. Okay, so let me go ahead and save that config right quick. And then we'll do the same thing here. We'll do show run interface VLAN 21. Okay, save that config as well. Okay, so go back over to 3. As I'm seeing things, I'm like, did I do that on the other switch? We're going to go ahead and save that config. We're going to jump onto 4 and admin login feature EIGRP router EIGRP1 log adjacency changes. Router ID is going to be 10.0.0.4, and then we're going to do interface ETH 1/6 IP router EIGRP1 interface VLAN 200 IP router EIGRP1 and then IP passive EIGRP1 and show IP EIGRP interface. Perfect. Okay, now that we have all that done, let's go ahead and focus on getting the CSRs up and running. So I'm going to come over here to CSR. Where is he hiding? 14. Where's 13? 13 somehow managed to get all the way over there. Okay, so in CSR 13, do a show IP interface brief. I'm just going to do a simple route advertisement where I'm going to go through and advertise all the networks 10 splat 8 on 13 and 14, but I'm not going to do it on the interfaces facing the WAN internet edge. And the reason why is because on the WAN internet edge, I'm actually going to be doing OSPF here between these guys, because I am on the Palos, they only support OSPF and BGP. So I'm going to form an OSPF adjacency between Nexus 7 and CSR 15 to the Palos, but I'm going to do but it says in the lab guide to form OSPF adjacencies with WAN internet edge devices. So that's what I'm going to do. So it's going to be EIGRP in the core, but OSPF to the WAN and internet edge connection. So we're going to follow the lab guide. So it should be pretty straightforward. Let's go ahead and continue this process. So let me go ahead and get out of the way. So up here, I'm going to go to global config, router, EIGRP1, and then network of 10.0.0.0, 0.255.255.255. Anything starting with 10, I'm going to enable EIGRP on. And then I should start to form adjacencies on those interfaces here momentarily. And then let's make sure that I can, I didn't create a network on that. So on interface gig 4, IP address here is going to be 10.3.13.13/24. No shut, because I added that after the fact. So as soon as the interfaces come online, we should form an adjacency once the interface comes online. Give that a couple seconds. We're going to do ping 10.3.13.3. Let's make sure the Nexus 9K3 on Ethernet 1.6 is good. We're going to do a show IP interface brief. Ah, my bad. Show interface status. That would explain it. So interface ETH 1/6. Show run interface ETH 1/6. Yep, that would explain it. No shut. And 13. We're going to do a show IP EIGRP neighbors. Show run. Oh wait. Show run EIGRP. Okay. Let's go back to 13. Try to ping that again. Let's see what's up at 3. Show IP, show interface status. Connected full. Show run interface ETH 1/6. Oh, I didn't give it an IP address. IP address of 10.3.13.3/24. That would explain it. Duh. Okay, so I make trivial errors every once in a while. Like, why is this not working? Okay, so, show IP EIGRP neighbors. Bam, that looks good. I'm going to go ahead and save that config. So I was kind of a dork. That's okay though. So show interface status. I'm going to interface ETH 1/6. IP address here will be 10.4.15.4/24. Show run interface ETH 1/6. No shut it. Wait, oh, wrong IP. 15. And then no shut. There it goes. We're going to save that config. Now I'm going to go to CSR 14, which is right here. Router EIGRP 1. Router EIGRP. Did I? Yeah, it should automatically pull the loopback address as the router ID. But it does say the loopback address, loopback 0 interface should be the router ID. So I'm going to type in EIGRP router ID is going to be 10.0.0.14. And then we're going to type in network of 10.0.0.0, 0.255.255.255. And I should be able to form adjacencies with everything. So that's a good sign. I was able to form an adjacency with 21. Let me see. I don't have 10.1.14. So let's see what's up with that. Nexus 1. Show IP interface brief. Show run interface ETH 1/5. Okay. Show IP EIGRP neighbors. Interface. Show run EIGRP. Am I running passive default? I'm running passive default. Like a dork, I'm running passive default. No passive default. There it goes. So that's a good sign. So now there's an adjacency there. So we go to Nexus 1 and then do a show IP route. I should be learning EIGRP routes. And I am. I see that connection right there. That's a good sign. Okay. Same thing with Nexus 2. Let's go over to 9K7 and get that one configured. So this is where I got to be a bit more judicious in my configs. I need to go to 15 and 7. So let's go do this on 7 first. Go to global config. And on 1, let me go ahead and save that config. On 7, I'm going to go to feature EIGRP and feature OSPF. Okay, so router EIGRP 1. Router ID is going to be 10.0.0.7. And then we're going to type in log adjacency changes. and I'm going to go to interface ETH 1/1 through 3 IP router EIGRP 1. So I should form adjacencies over those connections momentarily. So let me just make sure that show IP interface brief. Okay, good. So show IP EIGRP interfaces. Okay, I'm looking at peers. Good. So show IP EIGRP neighbors. Okay, cool, we've got neighbors. You know what? I know what I show run pipe include logging. Yeah, logging con 7. That helps when you have that turned on. Okay, and then what I'm going to do is router OSPF 1. Actually, you know what? I'm going to hold off on that because I want to just get the EIGRP capability in place, and then I'll focus on the rest of it later. So let me get EIGRP squared away first before I jump ahead. So CSR 15, I'm going to jump up here. I'm going to go to router EIGRP 1, and I'm going to type in do show IP, or say EIGRP router ID is going to be 10.0.0.15, and I'm going to type in do show IP interface brief, and I'm going to go 10.15.26 and 10.7.26. Or sorry, 10.15.26 and 10.15.27. So E4, gig 4 and 5, I'm not going to enable EIGRP on. So I'm going to go type in a network of 10.13.15.0.0.0.255. So that gets my connection to CSR 13 up. I'm going to do 7.15, which gets me the connection to Nexus 7. That gets up. And I'm going to do one, and I don't have one, gig 3, so interface gig 3, and I'll type in the command here just so that it's done. 4, and then I'll go interface gig 4, I'm sorry, gig 3. Type in IP address here will be 10.4.15.15/24 mask, and I'll no shut that. And then after a minute, I should form, as soon as the interface comes online, I should form an EIGRP adjacency with Nexus 4, and I do. So do show IP EIGRP neighbors. Perfect. So I'm going to save that config. Now that I have that in play, everything else is looking good. Now what I'm going to go do, since I've got the core up and running and I've got connectivity, is do some basic testing, right? I'm going to come down here. Let's see, I can grab, let me look at switch 21, for example. Switch 21 is over here. So I should have, let me go ahead and get out of the way. I should have a show IP route, and I should have a bunch of routes on the routing table. So I should have the 172.31.200 network in here. I should have all of my transit subnets to get me pretty much everywhere in the network I need to go, which is what I want to see. I see 10.1.10.21. I see 10.1.20 and 21, which are these guys. So if I go from switch 21, if I ping 10.1.20.72, I should be able to ping PC72, and if I ping 21.73, I should also be able to ping PC73, which is what I can do. Now we'll get into more specific testing once everything is working, but that essentially tells me that I can connect back and forth. So I'm able to route from one to the other. If I do a trace route to 10.1.20.72, source address, numeric display, yes. I am going to go from here. I hit CSR 14, then I route down to Nexus 1, and then I get down to 10.1.20.72 because I'm inside the VLAN. So that's working the way we expect it to. Okay, so the next step in our process here is I'm going to hold off on the WAN edge, WAN and internet edge for right now. What I am going to go do is I'm going to scroll all the way to the bottom because I want to get the data center online. Data center says the last two objects here are to apply the VRF to ETH1/2 on both of the leaf switches, form eBGP peering to the core, which means CSR13 and CSR14 need to have BGP enabled on it, and we're going to use ASN 65001 based off of what we see right here. This is our ASN. So I'm going to go ahead and do that and pull up the PDF again. So I'm going to go, let me go ahead and set that up here. And then we're going to have to do a little bit of redistribution. I hadn't thought of that ahead of time, but it's there. Even so, let me talk just briefly on that point. What happens if you have to do something that isn't stated? I know I brought that up before when we were looking at this trunk link between switch 21 and switch 22. Do you actually configure the trunk link because it would make sense to do so? The answer to that question is no. It's not required in order for things to work. However, if you're in a situation that isn't specifically detailed, and in order for it to work, you need to do something that isn't listed. So in this case here, if you need to form an it says form eBGP peering to the cores. It's dictated. It doesn't tell you anything about the details other than what you need to do. But we're running EIGRP in the core. So what do you do in that situation? Do you just do the bare minimum and don't do anything that they don't say? The answer to that question is no. In order for communication to happen, and there would be verification outputs that I don't have in here, in order for this to work, you would need to go through and do redistribution between BGP and EIGRP and BGP. So it's mutual redistribution on both sides. Now what that basically enables us to do is I have to make a call on where I make my where I do something that isn't specifically dictated to you to do. And that's where understanding what you need to do comes into play. So with that being said, if you need to do something that isn't specifically defined, but you know is needed in order to get reachability to work, you do what you've got to do. But down here, you don't need the trunk set up between these guys in order to do routing in between the two. That's not required. It's an optimization, yes, but it's not required. So let's go ahead and knock that out real quick. So I'm going to type in router BGP 65001. I'm going to type in no BGP default IPv4. And I'm going to type in router ID, it's going to be BGP router ID is going to be 10.0.0.13. I'm going to type in neighbor is going to be 10.8.13.8, remote AS of 65,002. And I'm going to type in address family IPv4 unicast. I'm going to go ahead and activate that peering. And I'm going to do the same thing, and that's the only one I have to do it for. So there's nothing more than I need to do. So I'm going to go ahead and exit out of here. I'm going to do CSR14, do the exact same thing. So router BGP 65001, no BGP default IPv4, neighbor of 10.10.14.10, remote AS 65002, address family IPv4, activate. That's all you have to do for right now. We'll come back to the redistribution here in just a minute. Now I'm going to jump on to Nexus 8 and 10, respectively. Admin. And if I do show run interface ETH 1/2, nothing's there. So interface ETH 1/2, I'm going to type in no switch port. I'm going to say VRF member is going to be enterprise. IP address here will be 10.8.13.8/24. No shut. Okay, that brings the interface online. I'm going to ping VRF enterprise. Ping, oh that's right, 10.8.13.13 VRF enterprise. Make sure I can ping it. And I can. That's a good sign. If I can ping it, I know everything's working the way you would expect it to. Now I get to go to router BGP 65002. Underneath VRF enterprise, I need to type in neighbor of 10.8.13.13, remote AS of 65001, and then address family IPv4 unicast. So now 13 should have a BGP peering, and it usually takes about a minute for it to trigger. There, it's up. And if I come down here and I do a show BGP IPv4 unicast summary, I'm learning some routes. And if I look at these, I'm learning 77 and 59. So you might say, well, why am I learning these from here? And there's an interesting use case for that. So let me go ahead and do the other side next, and I'll walk you through the rest of the config. The short answer is because that's how Nexus 9K8 sees them. We don't have a peering up here yet. If we had active communication going back and forth between these guys back here, you'd see more showing up. But because the fact that this guy here is technically, you're terminating an EBGP peering on a leaf switch and not a border, that's the reason why things look like that. When we go over to do the colos later on, things will look a little bit differently. But for right now, that's just the way it is. Oops. There we go. That was weird. 1 second here. Oh, so I was like, where'd my video go? It scared me there for a second. Okay, so what I'm going to do is on CSR 14, I've got that peering there. I'm going to go to Nexus 9K10, log in as admin and admin. I'm going to go to global config, show run, interface eth 1/2, nothing there, interface eth 1/2. VRF member enterprise. IP address here will be 10.10.14.10/24 and no shut. Do router BGP 65002, VRF enterprise, address family it's already there. So neighbor of 10.10.14.14, remote AS of 65001, address family IPv4 unicast. 14 should have an adjacency here in just a moment. And there it goes. And if I do show BGP IPv4 unicast summary, we're learning 4 routes, and we're learning the other side. This guy here is learning 76 and 56. Because that's how Nexus 9K10 sees them. Now, I've got those connections up and running now. And if I look at Nexus 9K10, if I do a show IP route to VRF enterprise, I'm going to see some stuff coming down from the outside, right? Actually, I take that back. You won't see anything coming from EIGRP because we haven't done redistribution yet. So I'm going to go back to CSR 3. I'm going to go to global config. I'm going to go to router BGP. Actually, I need to create some route maps first. So what I'm going to do is I'm just going to create some really, really basic route maps. I'm not going to do anything fancy with the route maps other than basically a permit statement, because there's nothing I need. I could do it a couple different ways. I could either A, create prefix lists that match on specific routes that I want to allow into the data center. So traffic coming out from the outside, the HQ, the spokes, other locations, stuff like that, the internet, I could allow some of that stuff in via prefix list into the data center, right? But traffic coming out of the data center is probably just going to be whatever's in the data center is going to be allowed to be seen. That's using prefix lists to match on what can be learned by the data center or learned from the data center. So advertised from the data center or learned by the data center, right? So one way is in, one way is out. And then I can call that from a route map, and then call the route map through redistribution, and the filtering will take place through the prefix list. That's one way to do it. I'm going to just do a basic prefix list that's basically BGP to EIGRP, EIGRP to BGP, and it's going to be basically a permit IP any, just so we can get reachability there. You're going to see a lot more stuff showing up on the Nexus switches. This is a lab So you may not, there might be some more specific requirements when you're sitting in the lab. So what I'm going to go do is on 13, I'm going to create route-map rm underscore bgp to EIGRP, and that's it. That's an permit IP any. So I need to come up here and do EIGRP to BGP. Exit out, and then I need to go to router BGP 65001 underneath the address family IPv4 unicast, and type in redistribute EIGRP 1 with route map, and I'm going to call the route map name, which is going to be, I'm in BGP bringing EIGRP routes in, so this is going to be EIGRP to BGP. Okay, and then if I do that, EIGRP to BGP, I should come over here to Nexus 9K8, and all of a sudden now, look what we see. Whole bunch of routes just got advertised to me. If I jump out of here and I do a show IP route VRF enterprise, I'm going to see a whole bunch of stuff in here that wasn't there before. Whole bunch of stuff. But that's how reachability works when you do redistribution. Now on 13, I'm going to do the same thing to router EIGRP1, redistribute BGP 65001 through a metric of, and then route map, and it's going to be BGP to EIGRP. So things that are coming out of the data center and into EIGRP, just like that. And if I do show IP EIGRP topology, we're going to see a bunch of additional routes. Namely, we're going to see, I'm looking for 172.16. Here's 101.59. That happens to be this server right here. This server's coming in from the outside world. If I do a show IP route, I should see external routes. I'll see 172.16, 177. It's being learned. Okay, so on the CSRs, it's going to be learned via BGP here locally. But if I jump over here to, say, switch 21, which is right here, and I do a show IP route, I'll see it as an external route, 77 and 59. So can I ping that? Can I ping 172.16.100.77? I should be able to, and I can. If I do a trace route to 172.16.100.77, source address, and I do numeric display, I should hit my default gateway. I should hit CSR 14, then I go over to CSR 13, then I jump across to the Nexus 9K8, then I jump across the VXLAN tunnel to 172.16.100.77, and then eventually I end up hitting my endpoint that I wanted to talk to. So we have reachability into the data center, and the fabric is built. So now I'm going to do the same thing on CSR 14. I'm going to do CSR 13, show run pipes, pipe section route dash map and router. So I'm essentially going to do take notepad, and then we're going to grab all of this right here, and I'm going to go ahead and schwack. I've got, oh, I forgot this one. I meant to grab all this. Grab all this, scoot this over. We're just going to need to do a little bit of manipulation here. Oops, grab this right here. So I don't need this right here. That can stay, and actually this needs to be moved up here to the top. So there's the route maps, and I don't need this command right there, and I don't need that. I do need, whoops, I got rid of the wrong. We need to get this in here. Go ahead and schwack that. Okay, so this is what I need here in order for this to work. So I have my redistribute statement underneath EIGRP to BGP, and I got BGP to EIGRP with my route map. So I'm just going to go ahead and copy and paste all this into CSR 14. All right, so I'm going to go ahead and hit the enter key on this one and do a show IP route. We should start to see stuff coming in. So what's going to be interesting about this, and if the routing doesn't make sense to you, that's okay. Let me go ahead and minimize this real quick. On CSR 14, we're going to see 177 and 101.59 as external routes from CSR 14, and they're going to be coming from the peering here. But we'll see BGP wise, we'll see 156 as local attached. So what I'm going to go do, and the same thing with CSR 13, we should see the same thing, show IP route. So if I bring this down here, you're going to see 156 coming from 10, 13, 14, right? And then you're going to see 101.76. So it looks like it's being learned this way, which it technically is. It's being learned over this peering, and that's because we don't have BGP between CSR 13 and CSR 14, but you don't want that there. You don't want to extend BGP too far into the core if you don't need to. So essentially now that we have everything set up the way we need to, we should have reachability. And this is an expected behavior. This is 100% the way that you would expect to see it working in this environment with the way that we have the networking set up. Now, did I do this correctly? Theoretically, it's improperly designed from the HQ data center. And I actually have a customer with this exact same design working today. Connected outbound to a pair of core routers, and it works. It's just a little suboptimal. So the reason why we see what we see is the way that VXLAN advertises stuff back and forth is from CSR 14, or let's actually look at it from here. Do a show BGP IPv4 unicast. What we're going to see from 10.8.13 right here, we're going to see 56 right, sorry, no, this one right here. We're going to see 59 right here. We're going to see 77 right here. The reason why we're going to see these, I wish this would go away. These two right here, let's log out. I wish I could make this wider. Anyway, the reason why you see these guys right here learn from here and not from here, from CSR 14 is because of how we're peering to them. Nexus 9K8 sees them via BGP across the VXLAN tunnel. That's why we see it that way. So because from this side here, they're locally attached. So CSR 14 is going to see them via BGP because they're directly attached through that. But because of the fact that we're doing redistribution into EIGRP and the route propagation, the moment you bring traffic in, and this is what I suspected with another customer, I labbed it up just like this, and we had the same scenario. Now, if I was to shut down the link to one of these connections, I'm not trying to go through an in-depth discussion of how this would come into play, just a high-level breakdown. If I was to shut this peering down, CSR 13 would lose some of the routes, right? Because we're not learning everything in, so we need both peerings up in order for this to work, unless we were to do dual peerings down, and then we'd learn everything from both. But that's another discussion altogether. So we're going to see those routes as we are. Now here, there is an optimization. You can go on the leaf switches. Typically this will be done on a border gateway. So actually, let me go ahead and scoot this over here a little bit. The way that you should properly design this is not this way. This is an improper design for what we want to do. Technically speaking, we need a border gateway. And what we would do, the proper design for a VXLAN fabric is with this right here. We would want spine, leaf, and attached devices, and we want a border gateway so that the leaf switches would form VXLAN tunnels with each other, and so would Nexus 53. So there'd be VXLAN tunnels between all of these guys, and then these devices here would be learned via Nexus 53 via the VXLAN tunnel, and then we form an eBGP peering to XR47. we would then point to this guy, and then he would point to the VTEP that actually owns the device. This is the proper way to do it. 2 leaf switches, spine, and then a border gateway of some type. That's the proper way to do this. Doing it like this, over here, you're going to get a weird routing paradigm where CSR13 is going to learn from Nexus 9K8 77 and 59. That's because they're being learned that way. You're not going to learn the directly attached routes. You're going to learn the opposite routes. So 14 will learn 76 and 58 over this link because that's how this switch is learning them. And vice versa with Nexus 9K8, he's learning 77 and 59 from 10. He's advertising those to CSR13. That's why we see basically a crisscross of learning. It's not properly put together, but in this particular situation, just because it's not best practice doesn't mean it won't work. And there are cases where you'll run into scenarios like this where this might be, and this same customer that I'm talking about actually has VPC connections downstream to servers and other switches. So this is actually an Anycast VTEP in a term, and we're doing BGP peerings down to it, but it doesn't matter. It's what we needed to do because they weren't willing to sacrifice redundancy in the data center, and it makes sense to have proper routing in the core. That they just weren't allowed. They had too much routing in their data center, and completely understood where they were coming from. So that's how we put it together. And I'm basically taking their design. I'm taking quite a few designs that I've walked into and putting them into this lab and walking you through how to set them up so that you can get them working. That's essentially what's happening here. So for just a little bit of testing, we're going to go ahead. I'm going to get out of the way, and I'm going to go ahead and pull up this guy here again, and I'm going to go all the way over here to, let's go to server 59, and we have PC 66. So let me go ahead and come over here to PC 66. Actually, let me do it on server 59. That makes more sense. Let me go ahead here and type in username, admin, privilege level 15, password Cisco. I'm going to type in line BTY 0 space 4, transport input telnet, and then we're going to say login local. Okay, so now I'm going to go over here to PC 66. Should be PC 66. I'm going to go ahead, I'm going to ping. In this case here, we're going to be taking a look at 172.16.101.59. Should be able to ping it. Show IP route. Ping 10.1.10.1. Okay. That should be routable. Maybe I've got the wrong. What is it, 100? Okay, so we have a routing issue. So this could be a verification step. So from switch 21, so I'm trying to go from 23 from PC 66 to SRV 59. So let's do a little bit of troubleshooting here. So come back over here a little bit. SRV59, show IP route, show IP interface brief, ping 172.16.101.1. Okay, I can ping that. Can I ping this down just a little bit? I want to be able to ping, I gotta bring this down further. I want to be able to ping 10.14.21.21. Okay, I can ping that. I should be able to ping 10.1.10.66. Okay, so there's a problem there. So what I need to go do is make sure that CSR 14 show IP route for 10.1.10.0. It's in the routing table. So that's working. So 21 should see this route as well. Show IP route for 172.16.101.0. And he sees it as an external route. Let's go to CSR 13, and we're going to look in here 10.1.10. So the routes are being learned the way that you would want them to, which is good. So why am I've got no IP routing turned on. So ping 10.1.10.66. So I'm this guy right here. Let's ping locally. Ping 172, or sorry, ping 10.1.10.66. Okay, so that's better. So it was an ARP entry. Ping that again, and now from, let's see if I can ping from server 59 again. Let's see if I can ping it. And I can't ping it. Is Nexus 9K10 learning it? Or in this case here, Nexus 9K8. So I see a bunch of stuff in there. I'm going to say undebug all. Do a show IP route VRF enterprise. What am I learning? Actually, let me do term. When you see something like this looks all gobbledygook. You got to go terminal with 150. And you're going to get it fully populated. So I am learning the route. 10.1.10, 10.1.11. Okay, so that's working. So if I was to ping 10.1.10.66 from VRF Enterprise, it's like it doesn't know how to get there. Let me go to CSR 13 and let's ping sourcing from, let's see, what are my options here? Gig 3. Gig 3. I'm not blocking anything. Can we do a trace route to 10.1.10.66 sourcing from gig 3? Oh, Control Shift 6 on this. I want to go ahead and add the numeric capability. Control Shift 6. There we go. We're going to do numerically. So I hit 21, and 21 seems to not know how to reach it. Okay, so this could be a switching issue. Show HSRP, or sorry, show standby brief. So 21, oh, you know why? Okay, so 22, so let me do 67 instead. Let me go to switch 22, make sure that he's all squared away. Show IP, EIGRP, neighbors. I cannot spell EIGRP neighbors. No neighbor. Okay, that explains it. That's why it's not working. Because this is the gateway. So that just proves to you right there that if you make a mistake, that's one of the reasons why traffic won't get to where it's got to go. Okay, so the routes are being advertised. So if I'm going to do a show IP EIGRP interface, interface, gig 0/0 is enabled, but I bet you show run pipe section EIGRP, passive interface default. It should not be doing that. That might be a bug. Show, let's make sure that Nexus 9K7, oh, you know what? I bet you that's the problem. Admin, show run interface ETH 1/4. Aha, that's the problem. Interface ETH 1/4, IP router EIGRP 1. Form the adjacency. Go back to 22. Adjacency is up. Router EIGRP 1, passive interface default, show IP route, show IP EIGRP neighbor. Wait. Show run section EIGRP. Okay. Router EIGRP 1, no passive interface, gigabit 0/0. Okay, the adjacency is up now. Show IP route. I'm learning those routes in now, and I see all these connections coming in. So now if I go back to server 59, and I try to ping 66, there it goes. That's exactly what I'm looking for. So if I go back to PC 66, wherever I left him, I forgot where I put him. Pretty sure it's right over here. PC 66, and I try to ping 59. Oh, wait, sorry, it's 101. My bad. Control Shift 6. It's 101. That'll work. If I try telnetting to 172.16.101.59, admin, admin. Give that a second to admin, admin. Whoops. It didn't like that. Whoops. But the point is that I can reach it. Control Shift 6 X. So because I can ping it, and if I do a trace route to 172.16.101.59 numerically, I hit my gateway. Oh, okay, there it goes. 7.15. Then it should jump across here to 13, then to Nexus 9K8. Okay, Control Shift 6. Why is this not working? Now I can't ping it. Control Shift 6. Can I ping 100.77? Can't ping that either. What is going on here? So now we're in a troubleshooting scenario. So is this possible in the lab? 100%. You might be trying to figure out why you can't get to somewhere and it doesn't work. So now you got to dig into the problem. Why is part of my connectivity working and part of it not? PC 67. We're going to go ahead and let me just make sure on try to ping 172.16.101.59. Okay, now it's working. Let's try PC 66 again. I wonder if switch 22's got a problem. So we'll do our testing from 67. So if I tried to telnet to 172.16.101.59, admin, admin, you know, it's my luck that, where is it? Server 59. Let me go to global config, username, admin, privilege level 15, password, admin. Try that again. Admin, admin. There we go. Okay, so there we go. So now I have my connection into the server, and if I was to exit out and do a trace route to 172.16.101.59 numerically, I'm going to hit my gateway on 21, then go to CSR 14, then CSR 13, then jump over to CSR or Nexus 8, jump across to Nexus 10, and then land on where I've got to go. So that's exactly what you'd want to do. So for whatever reason, switch 22, and I will do a little bit of investigation as to why that's giving me heartburn. Let's see what 22's got to say for itself, because let me do a show IP EIGRP neighbors. Neighbors there, show IP route. It sees the routes. stuff is there. So I should be able to ping 172.16.100.56. I should be able to ping 177. Should be able to ping 101.59. And I should be able to ping 101.59 and 76. Okay, so that's all working. So let's do a show IP EIGRP interfaces. Good. Show run section EIGRP. Show run. So I've got my 2 subnets advertised. Okay, so everything looks right. So if I do the same ping test, but I source from VLAN 11, which is actually VLAN 10, this is where the problem comes into play. So for whatever reason, the gateway is being problematic. So show run interface VLAN 10, 10.1, 10.1, exactly. Okay, so for whatever reason, that's giving us heartburn. So in the real world, I'd have to start digging into this problem, figuring out why this is not working. Why I can ping from, I can't source traffic from my SVI or, other subnets, PCs that are down here hanging out these switches. Why is that not working? But could I ping 10.1.10.66? Can I ping 68? I can ping all those, but for whatever reason, from the switch outbound, and I've only got one EIGRP adjacency, right? I'm not dealing with anything, there's no super specific routing here, but so let me pause right there and say that normally this is where you would do dynamic routing over this inter-switch link. You would form the trunks, and then you would be learning EIGRP routes over this guy right here. So even if you did have uplink issues this way, or what have you, you'd still be able to send traffic this way to wherever it's got to go. So that's really where that comes down to play, is what's going on there. So I'm going to leave it alone for there. Now, one other thing that I didn't want to mention, but real quick before we're done, is typically speaking, you're normally not going to do this. You're not going to come in with your EIGRP configuration, or sorry, your BGP config on your leaf switches for your VXLAN fabric. Notice how I've got a bunch of /32 routes, right? These /32s, that's a lot of subnets. Imagine if you had hundreds of servers, you'd have hundreds of /32 routes in your routing table. There's a better way of doing that, and that's what they refer to as aggregate or summary addresses. So on your switches here, you would configure aggregates for all of your subnets. So you would advertise summary routes instead of your more specific routes. So you would point traffic to the leaf switch that's advertising the route, and then once it's in the fabric would know where to go. So with that being said, that is what I wanted to show you guys and get working. So let me just do one little more test. Let me make sure I can get connectivity from everything. So PC72. Let's go to Nexus 1. Let's see what's going on with that. Nexus 1. Show IP route. I'm learning a bunch of stuff. So I'm going to do a show IP interface brief and show VRRP. I am the master for VLAN 21. So I'm going to ping 172.16.101.59. Source interface is going to be VLAN 21. No problem getting there. And if I was to go down to PC73, which should be in VLAN 21, if I can get there from Nexus, PC73, right there. Show IP interface brief. So I should be able to ping 172.16.101.59 all day long. Can I telnet to 172.16.101.59. Admin, admin. A little sluggish, but at least I'm in, right? Okay, perfect. So Nexus seems to be having no issues. It might be a catalyst issue, but that's okay. So now we've got a couple other scenarios. We could do server 61 and server 60 to VXLAN, but as far as I'm concerned, everything else looks good. So at this point in time, I'd be happy, and the key thing you'd want to do is you'd want to make sure that you have whatever verification you need to do to verify that your tasks have been completed successfully, your outputs match as closely as you possibly can. There are some things that you're not going to be able to verify or map exactly, but 99% of the time you're going to be able to. A scenario would be if you're doing ECMP forwarding, you're not going to be, maybe in the output it's .2 then .3, and you've got two different next hops because you're equal cost multipathing. But in that case there, you might see .3 then .2. It's just how the forwarding engine, the FIB, forwarding information base, or CEF, depending, and since we're dealing with enterprise, Cisco Express Forwarding is going to forward the traffic. So even if you see .3 then .2, when the output says .2.3, I did actually ask the proctor, I raised my hand, and I had the console for a particular router up, and I had the verification, and I said, is this going to be a problem? And he tapped me on the shoulder and said, you should be fine. And that's all he said. And then he walked away. I won't say who it was my proctor, but he just walked away. That was my third attempt. I wasn't going to put any more time and effort into it because I knew that it shouldn't be a problem. But you know what? When in doubt, you're always going to over-verify, and that's something I definitely did a lot in that lab exam. So with that being said, that is all of this right here. So we have our EBGP peerings outbound. We have a redistribution in place. We have our routed core is good to go. The next thing we're going to do in the next video is going to be our WAN Internet Edge. Get that all squared away, and then do our redistribution on right here to get all that squared away so that we can go continue getting this site completely operational. So thanks so much for stopping by and hanging out with me. If you have any questions, please like, share, and subscribe. Comment down below if you have any questions, comments, or just want to say, hey, this is awesome stuff. I will catch all of you in the next video. Have a good one, guys.